3.7 is the last section we'll do. There will be a test coming up quickly and a quiz probably quicker than that. So everything that we've done so far in this unit has been in preparation for this conclusion. And it's really all about just making arguments, which is something you do every day. And now you'll see mathematically when certain things actually make sense and when they don't. But a lot of times when we're doing these, you guys, even if you just say out loud what is happening, it'll make sense whether or not these are valid. Okay? Yes. Yes. So, a valid argument. The last column of the truth table is all true. Okay? And clearly, anything that's not valid is called an invalid argument. So if we see something that does not have all true, a mixture of truths and falses, or all false, we say it's an invalid argument, or a fallacy. That's the short way. So we got valid and invalid. Okay? Here's an easy example to kind of get your feet wet with arguments and making sense out of this. Okay? So if you get at least a 95% average on homework, then you get a 2% bonus. Okay? Let's say you do your end of the deal. You get your 95%. What should happen then? You get a 2% bonus. So the way we would say that is, therefore, I get a 2% bonus. Okay? And this is a valid argument. Okay? You can hear it as you read through this. So for example, if you were to argue with me because you did not get your 2% bonus, let's say, the very first thing you would tell me if you were to argue with me to try to get your points, right, would be, you told us that if we get a 95 on homework, we get a 2% bonus. And then I would say, yeah, you're right, I did say that. And then what would you follow that up with? Look at my, not yet, look at my homework average. It's above a 95. And I would say, you're right, it is. And then you would say, well, shouldn't I get, therefore I should get my 2% bonus. Okay? So those just go hand in hand. Now symbolically, here's what it would look like. So let's just use P and Q. Let's say P is, you get a 95% bonus, or 90, whoa, that's not what I meant. You get a 95% average on homework. Q is the second part of the sentence. You get a 2% bonus. Okay? So, premise one, or part one of the argument is a good way to think about it. If you read it, how do you translate this with symbols now? Just read the first one. If you get a 95 average on all homework, then you get a 2% bonus. How do you translate that with these letters?
P and then over Q. I always forget the arrow. Yeah, the arrow.
Good. That is correct. Okay. Is that a pass you came in with? No. Oh, no. Okay. That makes me so sad. Fortunately, it's not a absence because it's still, so you're just starting. Okay. No big deal. Premise two. How do you write, you got a 95% average on homework? That's just P, right? Conclusion. So here's my argument. Therefore, I get a 2% bonus, so that would be Q. So this is what it would look like symbolically. If P, then Q, P, therefore Q.
Are the three dots what therefore?
Yes, I was just about to say that. So you haven't seen these yet, right? Oh, now it looks like a bowling ball. That's not what I meant to do. This means therefore. Okay? Now, how you would write, because when we do a truth table, we've never done a truth table with like separate things like that. So there's got to be a way to put everything into one nice long argument. Okay? And so here's how you would do that. And it's pretty easy to remember. Okay? You just link all your premises or all the parts of your argument together with and symbols. So if we had three of them, you would write P1 and P2 and P3. You just link them all together with ands. And then comes the conclusion after the arrow. Okay? So starting up here, we would say if P, then Q, that's my first premise, and P, that's my second premise, and I'm done with all the premises, so now this gets lumped together. And now we do that followed by the conclusion. You actually asked about a question like this way back earlier in my math lab about it was actually an argument written out, and you were asking how to translate. I think John was asking about it. I don't know if you remember that. Okay? But that's exactly what that is. Okay? Yes?
So you don't need the three dots?
Not here. No. Very good question. The way you would read this is if P then Q and P then Q. Okay? And now we're going to prove, besides that it sounds good, right, why it actually is a valid argument. So let's use a truth table. Let's set it up. Why don't you guys take a minute or so and build the truth table for this argument right here. Okay, I see a lot of us on our phones, so that means we're ready to move on. What should happen here? The last column should be all true. If it's not, you made a mistake somewhere. Okay? Here's how you would set it up if you want to check. So first, you do your if then you connect that with the and symbol with the P. And now you can connect all of that with the Q, with the if then symbol. So that's the conclusion. When is the if then statement false? So that's it. Everything else, true. Now we connect third column with P, so that's the first and third. And when are ands true?
When both of them are true.
Both of them have to be true. So true, true, and that is it. Everything else is false. Now we are doing this column, then Q. So right here. When is an if-then false again? First one's true, second one, but remember we're going backwards, right? Because we got to follow the same order. True, true. And actually I don't see any other possible true falses because they're all false first. So everything's true. Okay? Since all truth assignments are true, it's a tautology. Okay, and obviously the argument is valid. And let me just write this again. This symbol means therefore. That's probably better than writing it in a circle so it looks like a bowling ball. Okay? Any questions so far? All right, let's take a look at next page. We're going to start to get bigger arguments now. Okay. And here's a recap. If you forget how to check if an argument is valid or not, this breaks down exactly what we did. Okay, so if you ever need a recap, here you go. Okay, let's look at example 2. Let me switch colors. Oh, they kind of need that, I guess, huh?
Yeah, it's not really.
Okay. So let's again use some letters here. I'm going to just use P, Q, and R just to make things simple. And here's the argument. If you score low on a placement test, then you must take at least one developmental math class. If you need to take at least one developmental math class, then you must take Psychology 106. Well, you scored low on the placement test. Therefore, you must then take Psychology 106. That's the argument. Okay, it's a little bit longer, but it's valid. And let's see why. So, P, I'm just going to say you score low on the placement test. Q is you need to take a developmental math class. And the last thing going on here is having to take Psychology 106. So that'll be my third sentence. You must take Psych 106. Okay. Now let's lay out the argument symbolically. Here's premise 1. If you score low, then you must take a math class. How do I write that? P then Q. Very good. Next one. If you need to take at least one math class, then you must take Psych 106. So now that's Q, then R. Good. Third one. This one's simple. You scored low on the placement test. What letter is that? Are you sure that's R?
P.
That's P. Yeah, careful. You're jumping ahead to the conclusion. The conclusion is R. Okay, so now we have a little bit more to work with here. And I'm going to give you a couple minutes, build the truth table, and verify that this is a valid argument. Okay? And you're welcome to use arrows or whatever. This column should be larger, the second to last column. So just, if you want to write it up here and then draw a little arrow, that's fine. So take a minute or two, and then I'll go over it. Oh, do you guys want to do the argument together first? I'm sorry. Like putting it all together? Okay. So again, here's your formula. You just take every line up here, every line, you connect these with ands. Those are all the big giant first part of the if-then statement, and then you do the arrow, and then your last part is just whatever the conclusion is. So it's going to look something like this. And since we're going to put it in the last column, I might as well just put it there. So first premise, if P, then Q. We connect that with the second one. So that's Q, then R. And now that gets connected with P, that's the third one. And then all of that is followed by R. Okay, so here's premise 1, here's premise 2. Put those together with an and symbol to make premise 3. And now all of that is your if, followed by the R, which is the conclusion. Okay, so set up your truth table, and let's see why this giant argument is valid. Waiting, don't wait for me to do it. You want to make your mistakes now. Yeah, so you need your three letters, right? Now, so if you're building to this, right? Before you can do the whole thing, you gotta do this column, make that a column, make this a column, and then the next one should be those two together, and then the third one should be almost everything. Right? And all of them.
True, true, false. And I went off of that.
Work?
Or just like some.
I already want a blue and false.
The only one that's false is just false.
Got a mixture, huh? Yeah. Maybe instead of throwing the packet at you, you can go through what happened there. Big one? I don't know what I'm doing. And then this whole front part is the little one on the arrow. It's got to be true. Good to clarify.
I was drawing.
And it can be tricky because if you're looking at the table from left to right, you got to make sure you go backwards if you need to.
I'm gonna have to redo this.
Okay. Here's what it should look like. So I kind of glanced over a lot of your shoulders, and basically I'm confident that if I saw this column, true, and then all false after that, and you got all trues here, then you did it right. Okay? Now, here's how you should have your columns split up. I'm kind of yelling so that my computer can pick me up, sorry. If P then Q, if Q then R. You got to do these two separately first, then you can put them together with the and symbol, so that's the next column. And then now you can put those together with the third one with an and. That's the third, the second last column. And now we already did that. That's the final thing. Okay? Are there any questions on how to fill out the table? Okay? At this point, you guys should be getting pretty good at these. Okay? You might make a mistake setting it up properly, but you need to be like 100%. Like if you have everything labeled for you, that you can just go in and do it. Okay? All right. Let's turn the page then. And let's talk about valid arguments but without symbols. Okay? And then I could probably stop after this because we're not going to finish today. All right. So, I think I mentioned this before, but the bottom line is you need to be able to determine if an argument is valid. And you're going to have two options for doing that. Number one, you do a truth table like we just did. And what needs to happen for it to be valid? All true for the last column. Okay? That's option one. Option two is you recognize what kind of argument it is. And so here are the four most common arguments that exist in the world, not just in math class. Okay? Direct reasoning is the first one and looks exactly like the first example that we did. If P then Q, P, therefore Q. Okay, and the one thing, you guys, I want to get you in the habit of trying to make sense out of things too without just looking at letters and going, yeah, that's right, or no, that's wrong. Come up with a quick example to see if this makes sense. Okay, you should be able to do that. Like here's a good one. I think we've used this example before. If you all get A's on the next test or quiz, what did I say I was going to do? Then I'm going to bring in donuts, right? So just listen to how this sounds. If you all get A's, then I will bring in donuts. You all got A's. Therefore, you get donuts. That's a solid argument, right? That's direct reasoning. Does that make sense? Okay, we proved it already. But if you see this, you're welcome to just say argument is valid. It's direct reasoning. You don't have to fill out a truth table unless you forget and you want to, but okay. So that's direct. Contrapositive. Starts off the same. They all start off with, most of them start off with an if-then statement. So if P, then Q. And so if you look up here, you see how the P comes first and then the Q comes second in this argument? Do you remember what happens for a contrapositive? You're thinking of negating. Contrapositive is you flip and you negate both, right? So instead of P coming first, now we would say negation Q, therefore negation P. Okay? Use that same example and you can see that it makes sense. If you all get A's on the next test, then you will all get donuts. Well, I didn't get you any donuts. That means you did not all get A's. Okay? That's contrapositive. Disjunctive. What kind of statement was disjunctive again? Or, very good. So we start with an or statement, P or Q, not P, therefore Q is the conclusion. Okay, let's, again, make up another silly example, and it should sound good, like convincing to you. Okay? Let's say P is, it's cloudy outside. Q is, it's sunny outside. Okay? So how do you say this? That would be, it's cloudy outside or it's sunny outside. And now this is red. It's not cloudy, so it's sunny outside. Does that make sense? Okay? Remember, an or statement, you need at least one thing to be true. So if one of the things is false, that has to be that the other one must be true. Okay, so that's disjunctive. Transitive, this is the last one. If P then Q, if Q then R, therefore if P then R. Okay? And again, make up a silly example and it should make sense. Let's keep it with the A's and the donuts. I really want to bring in donuts for you guys. You can clearly tell. Okay? If you all get A's, then you all get donuts. If you all get donuts, I'm going to have to spend a lot of money. You guys follow that argument? Let me say that again. If you all get A's, then you all get donuts. If you all get donuts, then I got to spend a lot of money. Does it make sense then that if you all get A's, I have to spend a lot of money? Yes. Connect the dots, right? So this is what we call transitive reasoning. Okay? Are there any questions on these four? Okay? That is good for today. So if you have questions that you want to